With this, do we have more angles than sides or sides than angles? After that, we can start plugging into this formula. We should look at the triangle and see if that makes sense. That's today on High Peak Education. Find the measure of angle C in the triangle below. Round your answer to the nearest hundredth of a degree. With this, do we have more angles than sides or sides than angles?
Sides and angles.
100%, because we have all three sides. Also, suppose I did 13 squared plus 17 squared. Is that going to equal 18 squared? It definitely turns out no. So this would definitely be an acute triangle, because 13 squared plus 17 squared is way larger than 18 squared. So when you have more angles than sides, you use the law of sines. When we have more sides than... Yes, we're going to use the law of cosine because we have way more sides than angles. Now, by the way, here's the little trick. Whenever you have only sides, you definitely can't use the law of sines because the law of sines needs an angle in the formula. In fact, it needs two angles, one of which has to be known, the other could be solved for. Now, the law of cosines has only one angle in the formula. So if you know all the sides, you could solve it. If it's doing the law of sines, it'd be sine of capital A over lowercase a equals sine of capital B over lowercase b, and then also with sine of capital C over lowercase c. But we're doing the law of cosine. Now think about this. Let's go through this quickly out loud in our head. But if c squared equals a squared plus b squared minus 2ab cosine sine capital C, we want to solve for capital C. So we need to add the cosine term over, and we need to subtract c squared over. So we've got a squared plus b squared minus c squared. We need to divide by 2ab and then take the inverse cosine, which is the arc cosine, which gives us the angle capital C when we know all the other sides. So indeed, it should look just like this. Capital C equals inverse cosine of a squared plus b squared minus c squared over 2ab. Now from there, you could just use all the sides. Capital A is across from side BC is lowercase a, which is 18 in this case. After that, we can start plugging into this formula.
Yeah.
So it's kind of a bit of a mouthful, but it's inverse cosine of 18 squared plus 17 squared minus 13 squared over 2 times 18 times 17. And you have to take the inverse cosine of that. Now, definitely need a scientific calculator for this. Make sure you obey the order of operations by squaring and adding these. Subtract the square of this one. Divide by the product of 2, 18, and 17. Hey, thanks for checking out High Peak Education. Do you need some one-on-one guidance? Go to our Calendly link and book a grade boost game plan. Or if you're studying for a standardized test, for a score soar game plan. At highpeakeducation.com, you can click book now or see our Calendly page. Okay, let's get back to today's video. So I think it's gonna be something like this. We've got inverse cosine of 18 squared plus 17 squared minus 13 squared over 2 times 18 times 17, take the inverse cosine. I think we get about 43.49 degrees for our final answer. Now, one more thing. Of course, we should look at the triangle and see if that makes sense. I don't see any obtuse angles, so it should be an acute angle. And 43.49 degrees, let's look at angle C. Angle C looks like it's the smallest angle. I'd say, that seems right. Okay, this is a little bit of a tougher one because, again, you had to know which law to use, how to manipulate the law. By the way, quick note, I would definitely recommend having this written down on like a note card or an equation sheet. This is one of those formulas that's like kind of hard to memorize, so I'd recommend having it written down somewhere. Use this formula to find an unknown angle in a non-right triangle when all the sides are given. C is the vertex and the sides are lowercase a, lowercase b, and lowercase c, corresponding to the angles as shown here. Okay, so that's the idea.